So we're going to now start looking at volumes. Before, what we cared about was we cared about the surface area. Like that's the area that was around an object, right? Now with volume and capacity, we're looking at the inside of an object. If I give you this thing here, this water jug, and I ask you to figure out the surface area, you should be able to do it. This part's a little weird, but generally speaking, you guys can come pretty close to this, right? You just do like 2 cylinders and add them up, or just one big cylinder. That'd be fine. So you can figure out how much plastic there is on here. But now what I care about is I want to know the space inside. That's what we're going to learn how to calculate today. And we have volume and we have capacity. And they're different things. They are different things. So volume is how much space is inside here. So I'm looking at how much I can actually like put in here. Just how much empty space is in this jug. Now when we measure a distance, we just say it's centimeters, right? When we measure a area, we square it. When we are looking at volume capacity, we're going to cube that information. So you're going to have that little 3 there. So you use like centimeters cubed, meters cubed. Each of those are fine. We're going to eventually learn how to convert those two. That gets a little weird, but we'll get there. So volume is how much air is in here. Capacity is how much it can hold. How much liquid can this hold? Usually we use liters or gallons or milliliters, right? Usually we want to know, sometimes you see ounces too, but like we have measurements that show liquid. So capacity is showing how much it can hold. Volume is showing how much space is in there. They are a little bit different. So just make sure that you are aware of that fact. And remember, so we measure volume in cubed units. Capacity, we look at liters or gallons. We don't say, oh, my jukes box holds 250 cubed milliliters. No, it just holds 250 milliliters, right? That's the difference there between a volume and a capacity. So, so one thing to note is if you ever need to convert this, so this is where we get the idea of 1 liter from. Like you think about those base measurements, like a pound, a liter, a kilogram, like a gram. All of those came from something. So we use water actually to figure out a lot of those weights. So what they did was they just took, you don't need to draw this. In fact, don't draw this. But what they did was they took a 10 by 10 by 10 cube. So it's 10 centimeters tall, it's 10 centimeters wide, and it has a length of 10 centimeters. So they took a 10 by 10 by 10 cube, they filled it with water, which gave them this, and then they're like, this is a pound, or this is a liter. They just said that that's going to be a liter from now on. So that's where we get that unit of measurement from, is they just took a little square, and they filled it with water, and we're like, that's a liter now. And then they used liters to figure out how much stuff weighs, is what it all comes down to. But this is just an important fact. So 1,000 cubic centimeters, we're going to say is a liter. It's just a fact we're going to need to remember. So I recommend you underline that or highlight that. So we're going to have 2 different formulas here to find something. So when we look at the volume of a prism, which is the 3D object, and a cylinder, how we find this is we take the base, the area of the base. So if I want to find the volume of this, I would take the area of the base, the circle. We know how to do that. We know how to find the area of the circle. And I would just times that by how tall it is. And that's it. We take the area of the base. Doesn't matter what shape we're doing. No matter what shape you do, what's the base times by the height, and that's your volume. So that's a universal law. Now, we have some pre-made formulas that will be given to you. You don't need to memorize them, but it's really helpful if you know that you take the area of the base and you times it by the height of the object. Oh, and I'll admit you in there. So even if it's some weird shape we haven't seen before, that's how you solve it. What's the base? Find the area of it, times it by the height. So we have 2 different formulas here for you. So I'll give you the first one here. So this first one is the area of a cylinder. So V equals pi r squared. Oh, that's the area of a circle, and H times height. It's just the area of that circle times that height. That's what that is. If you're given a shape, you don't know what it is. What if I gave you a triangular prism? And I'm like, hey, find the area of this or find the volume of this. You'd have to figure out the area of that base and you'd have to times it by that height. So this other formula here is a universal thing. In fact, I'm not going to box them. I'm going to highlight them. I recommend you box them or highlight them or something, star it. So it's a universal fact. Whenever we deal with volume, it's just it's the area of the base times the height. Okay, so let's look at an example of this. We're going to start with just a nice simple object, a rectangular prism. So rectangle, I'm going to quickly draw it. Rectangle. And then it's a prism, which means it's 3D. So I'm just going to extend all these lines out a little bit and connect them. Right, so now I have a rectangular prism. So it's saying it has a base that is 15 times 2. Now my base, don't color this in, but my base is going to be this thing here, right? In fact, you can if you want. You can shade it in like this. Oops, sorry. So my base is that stuff I drew those lines through, right? So it's saying the base is 15 times 2. So I'm just going to quickly put that in there. 15 centimeters, oops. Times 2 centimeters. And it's saying it has a height of 20 centimeters. So all I'm doing is I'm just labeling the three things. Oh, thank you, 12 centimeters, thank you. All right, so all of my, no matter what it is, all of my volumes are going to have the same formula. The volume is the area of the base times the height. So V, volume, is going to be equal to, I'm going to say A base, see like base in brackets there, times the height. Let me make this bigger here for you. Now, let's think about this. This is a little bit less blindly, what's my formula? What's my formula? Oh, it's this on the sheet and plug it in. You're not always going to have a formula for every single shape. But if we're looking at this, so this is a rectangle, right? What's the area of a rectangle? My base is a rectangle. What I drew in red there is a rectangle. Yeah, length times width. So what's my area of my base? Well, it's length times width times the height. That's where I get that L and W from, right? Well, I know how to find the area of a triangle or of a rectangle now. That was what we learned on day one of this. It's just length times width. So now all I have to do is now I have a complete formula, just like before. Now I can plug in the stuff. I know I have a length of 15. I know I have a width of 12. So 15 centimeters times 12 centimeters. And I know I have a height of 20 centimeters. And so if I times all three of those numbers together, (15 times 12). Oh, I'm plussing them. 15 times 12 times 20. I'm going to get 3,600. 3,600 what?
Centimeters cubed.
Centimeters cubed, right? So cube is going to be a little 3 here instead of a 2, right? Because that sort of represents the fact that I'm looking at the volume of it. Squaring is looking at the surface area. I don't care about the surface area. I care about what I can fit in that space. So it's going to be cubed. So this next question is a little weird, and this tends to be really confusing at first. The next question asks us to figure out the capacity of the first prism. Now, what we just figured out is the volume. Remember, the capacity is different. The capacity is looking at how much it can hold. It's looking at liters, milliliters, gallons, stuff like that. And right now, the only fact that we know is that in the metric system, 1,000 cubic centimeters is equal to 1 liter. So I'm just going to really quickly put that in here. So 1,000 cubic centimeters is equal to 1 liter, 1 L. So this is something I know already. I'll cube that. So this is just a fact I know. Why am I writing that down? Because that is a fact that we know. It's that thing I highlighted up there in the top. It's just a fact of how it works. But I know what I have. I know that the volume here is 3,600 cube centimeters, right? So now I want to figure out what the capacity, or rather, how many liters is that? 3.6. It's going to be 3.6. Now, you're right. How did you get 3.6?
Well, 1,000 centimeters cubes is 1 liter. 3,003 liters.
Yeah.
600.
Yeah. Yeah. What we kind of did in our head is, well, I just know this is just 3 times 6, right? So this is set up exactly like those ratios from the very first unit we did, technically. If you're ever unsure, you can set it up that exact same way. Most of the time, though, we're working with ones and thousands. We could probably just, it's going to be this. Like you can probably just jump there immediately to your head. But if you're ever not sure, oh, well, it's just like a ratio question that I've done before, so I can solve that. Again, all the stuff we're doing here, we can't just be like, okay, I don't need that anymore. You will need it. You can't just be like, oh, I don't want to learn that unit. I'll do the next one. You need the old stuff. So what's my answer? I have 4 different numbers here. What's my actual answer? 3.6 liters. I'm going to give that a quick circle. So that's how much it actually holds. That's the capacity. Now we can use this stuff to get a little bit more complicated too, if we really wanted. Not all questions are going to be like this. In fact, very few are, but we can also start applying some more algebra stuff to this. So this next question here is asking us if we have a different rectangular prism. So different rectangular prism, I'm going to quickly draw that. I always recommend draw it. Oh, I'm going to erase that line. That's not a straight line. Ooh. There we go. Okay, I fixed it, I think. I have a rectangular prism here. It is saying it has a square base. So, okay, I probably should have made this a square, actually. In fact, yeah, it's fine. So what this is saying is it's saying that the base here, it's a square. It's saying both of these are 7 centimeters. I know it looks like a rectangle. That's because I made a goof. I didn't read the question. I immediately started to solve it. So don't do what I'm doing. You want to read the question first. It's a square base. That's where I get the 7 by 7 from. So what it's saying is it's saying the volume itself, they're telling me what it is. It's 392, and they want you to find the height of this. Well, so just like before, I know the volume it's the area of the base times the height. So let's just put that in. So the volume is equal to the area of the base times the height. So all I now have to do is kind of substitute some stuff in. So first off, if I'm dealing with a square, what's the area of a square? Length times width, right? Length times width times height. So just like before, it's the same thing, length times width times height. In this case, I'm going to substitute the stuff in. I know what the volume is. Actually, I'm just going to do this instead. Do that. So in this case, I already know what the volume is. It's told me that. Do I know the length and the width?
Yes, 7 and 7.
Yeah, because it tells me that 7 and 7, but I do not know the height. Well, this is starting to look a little familiar. We haven't worked a lot with this stuff, but technically, isn't this? I'm just going to erase this 7 by 7 or down here, just to make some space. But technically, isn't this 7 times 7 is 49? Now, how could I find the answer to this? Because all I care about is I want to eventually figure out what h is, what the height is.
Would you go 392 divided by 49?
Yeah, I'm just going to do the opposite of what's happening. Well, what do I care about? I care about this h here. I need to get that down here. So I need to do the opposite of what's happening. What's happening to h? It's being times by 49 squared centimeters. So I need to do the opposite to both sides, which is divided by 49 squared centimeters. And so first off, I'm trying to find, make this red. So is h going to be a distance, an area, or a volume?
Volume?
The height. Is the height going to be? Am I looking at when I'm looking at height? Am I looking at a distance, an area, or a volume?
Volume.
Well, just the distance, right? If I want to know how tall something is, that's a height. So that means I'm only going to have just the centimeters. It's not going to be centimeters squared. It's not going to be centimeters cubed. It's just going to be just centimeters. And so now all I have to do is, well, I'm just going to do exactly what it said. What was that? Is that 392? I said I'm taking 392 cubic centimeters. I'm dividing it by 49. It's going to be 8. So my answer is going to eventually end up being 8 centimeters. We'll do 2 more questions here. With this one, there's not a lot. We're just looking at the more basic shapes right now. I'll give you a second. But so it can get more complicated than that. You're not going to encounter these a lot. We're going to look more at this type of math later on in the unit, later on in the next math as well. But we do need to have a little bit of algebra stuff with us. Now, if you take a look at the next question, though, on the next page, my question for you is, just tell me in plain English, how could I solve this? How could I figure this out? There's 2 ways. There's 3 ways. So let's start with just the volume. If I want to find the volume of this, how do I do that?
You have to find the area.
Well, I have to find the area of the base. You're right. So I'd have to find I'd have to find like this thing here. But overall, so you're thinking of how to solve it, but what's harder about this shape?
It's two shapes.
It's two shapes. I don't have a formula to find, I don't know, it looks like a stairs, right? I don't have the formula to find stairs. So how do we usually solve two shapes? Think about how we solved a lot of stuff in question 2. What do we have to do when we had those weird shapes? When I had a shape like this, how did I solve that? You split it. Yeah, you need to split it into easier shapes. Absolutely. So I need to split this. And there's two ways I can split it. I can either just split it into two shapes like this. That's one way. Or I can just split it right in half down the middle. Either's fine. Doesn't matter. There's also a third way as well, which we're not going to do, but there's a third way. I could just pretend that this part here is filled in. I could just pretend this is filled in here. So find the area of the whole little square here, or whole rectangular prism, find the area of the whole thing, and then just take away what this part is. I could do it that way too. So there's 3 different ways you could find the answer to this. All of them are acceptable. All should give you the right answer. That's fine. I'm going to keep it nice and easy. I'm just going to find the shape. I'm just going to cut it like this. I'm going to say this is shape 1 and this is shape 2. You could do any one of those 3. It'll be fine. So the second I'm dealing with a more complicated problem, what do we always write at the top? An equation. If I want to find the area, if I want to find the volume of this, sorry, the volume of this is going to be the volume of shape 1, V1, plus V2. So then just like before, I'm going to break it up. I'm going to figure out what is the volume of shape 1. So the second I'm dealing with volume, what's my formula to deal with volume? You're right. It's it's the area of the base times the height. So what's my base of shape 1, of the top one there?
On the top one.
Yeah, on the top one.
So
So what shape is it?
oh, like that sort of.
Yeah, it's a rectangle, which means it's length times width, right? If I want to find the area of a rectangle, it's length times width. And then all I now need to do is times it by the height. So what's my length of this shape? It'd be 9.4 centimeters. What's the width of it? Now the width of it is going to be the width of it is going to be this line right here, right?
Yeah.
And you're right, that is 7.5. If I'm ever unsure, like, I don't know which one it is, you can always use the ruler trick, right? Like, this is the line I'm trying to find. You can, without rotating it, keep it still, you can just move your ruler around until you find something that matches it. So if this line here, there's no number there, but if I keep going, I eventually find out that 6.6 works. If you're ever unsure, you can use that ruler trick. So the width of it is going to be, what did I say that was? 6.6? 6.6 centimeters. And then what's the height of it?
4.2.
It's 4.2, yeah. And so my total volume now, all I now need to do is punch those numbers in the calculators. 9.4 times 6.6 times 4.2. It's going to give me 260.57 centimeters cubed. That is an important shape. I'm going to underline it. So now, check. I've done volume 1. Now I just need to do volume 2, right? And then I'm done. So V2 the volume of shape 2 is equal to, so first off, what is the base of this shape? Oh, but like what shape is it? It's a rectangle. So rectangle, I'm going to skip this first step. I'm going to skip this area of the base. You can do this. So if you're dealing with a rectangle, oh, well, I know what the area of a rectangle is. It is length times width. And then I just times that by the height. So you can skip this first step if you really know what you're doing. But it's really important to understand what that length and width is. It is the base. We need that understanding to succeed next unit. That is why I usually start with this. The volume is equal to the area of the base times the height. That is an important understanding. I'm skipping that step here, but that's because, hey, we should know now that that length and this width here is just this area of this base. So I'm skipping that step, and you can do that, but you have to have that understanding. So now all I need to do is figure out what's my length and my width and my height. So what's my length? 16.8. What's my width? 6.6. What's my height? It would be that 7.5, yes. So cool, I have my three numbers. You know, that times that times that, all three numbers, you times them together, you're gonna get 831.6 centimeters cubed. Am I done? No, because my original formula at the very, very top was it's volume 1 plus volume 2. I now have both of those. So all I'm going to do is add that in. So my formula was V equals V1 plus V2. So V is equal to V1, which is 260.57 centimeters cubed, plus V2, which is 830.6 centimeters cubed. Again, the math itself is not hard. The calculator does all the work for us, but it's just setting us up to be successful is the important part. So I add those two up, I get 1,092.17 cubic centimeters cubed. That's my final answer. I'm going to circle it. Am I all done? No. And this is where it's really easy to make a mistake is, yeah, I found the volume. Good to go. Let's go to the next one. This question has asked us for two things, the volume and the capacity. It is really important. Always go. It's hard to get in the habit. Get in the habit, reread the question, make sure that you've answered it correctly. I've done the volume. I need to do the capacity now. How do I find the capacity of something?
1,000 centimeters cubed is 1 liter.
Yeah, so I know that, oh, if I'm using capacity, I need to turn centimeters into, we're going to use liters because that's the only fact we know right now. So capacity, I'm going to turn these centimeters into liters. So I know that 1,000 centimeters cubed is equal to 1 liter. I'm writing down what I know. What else do I know? I know that I have 1,092.17 cubic centimeters, but I do not know how many liters that is. Cubed. So there's a couple ways you could figure this out. You could take this number we have, divide it by 1,000, and that would work. So I could take this 1,092.17. I could divide this by 1,000. You could also figure out that magic number. That works too. Either of those methods will work. I'm just going to do that. I'm going to take, in fact, I'm just going to write that down really quickly. It is an example. You don't need to do this. You could just spit out the answer, but as an example, it's not a bad idea. I'm going to take 1,092.17 and divide it by 1,000. And if I do that, I should get, now technically it's going to be 1.09217 liters. We don't need to go that deep. we can just round that to 2 decimal points. So it's going to be 1.09 liters. And that would be fine. So you could either do that ratio stuff that we've done where it's, okay, I take 1,000, I times it by a magic number, and that gives me this. So I need to do that same thing over here. You could either do it that way, or you can just divide it by 1,000. Either is going to work. All right. So we got one more question here we can work on. Oops. So we'll do one more question together here, which is we're going to look at a can of tomato sauce. Now, first off, what shape is a can? It's a cylinder. So when I see can, I know that I need to look at a cylinder. Okay, completely off topic, but I found a can of like frozen, there was a can of beans under my car seat that I think has been there for months and is like frozen solid. And like, I don't know, I took it out yesterday and I put it in my sink and it just exploded. I was so mad. I don't know how long it was down there. I think I was doing groceries one day and it just fell out of the bag and under the seat and oh, it's not pretty. So off topic, but anyways, when you see can, you think cylinder. When you see pipe, you think cylinder. You have to envision what the object looks like. So what I have is I have a can. It has a radius of 3.8 centimeters and a height of 10.2 centimeters. I see they're in the same base units. I see I have a radius and not a diameter. So I can immediately be good to go to this. I'm going to quickly draw my shape here. You do not always need to do this, but it's really helpful to envision it. So I like drawing the object. So I'm going to draw a nice little can here. That's not a perfect drawing, but it works. So it has a radius of 3.8. I'm going to write that in. And it has a height of 10.2. This is a really bad drawing. That's fine. Cool. I have the radius. Remember, you can do nothing with the diameter. You need to turn that diameter into a radius if you have. So how do I find the volume of any shape? Well, not quite. It's the area of the base times the height. What shape is the base of a cylinder? What's the base of this jug? Circle, right? The base of this cylinder is a circle. So what's the area of a circle? Oh, well, what's the area of a circle? Like, what's the formula for an area of a circle? So we're gonna have to go all the way up to the very, very top of your booklet here.
Pi r h.
Yeah. So it's gonna be pi times radius squared, right? That's the area of a circle. So this is just on the 3rd page of your booklet. So I'm just gonna write that in. So it's gonna be pi times radius squared. You could just do times r as well. That works. And then it's times the height. So you always have to think, what is the shape that's the base of my object? And then you just plug that in there. So now all of a sudden I have all the stuff. I can make this work. Oh, I didn't mean to do this. I'll just type that in. Oopsies. Times h. All right. So pi is still pi. Your calculator has a number for that. Do I know what my radius is?
3.8 squared.
It's 3.8 squared. And where it's 3.8 centimeters squared. And where are you going to mess this up? You're going to mess this up if that's a diameter. That's always the tricky part there. That's the curveball. So you have to make sure, did it give me the radius? So it's 3.8 squared centimeters times the height, which is 10.2 centimeters. Oops, not 102, 10.2. So now all I need to do is just plug that in my calculator, right? So I'm doing pi. Where's pi? Pi times 3.8 squared. Or you can do times 3.8 times 3.8. Either works. Times 10.2. And if you do that, you should get, you need to change it a little bit, 462.72. So 462.72. How many centimeters?
Cubed.
Cubed. It is measuring volume. That means it is cubed. I'm going to circle that. That's my final answer. Now, the final part of this, we'll cut you loose after this, but this next part here is question B. How much tomato sauce in liters does the can hold? Well, liters is a unit of capacity. So, deal with capacity. Well, what's the one fact I know? I know that 1,000 cubic centimeters is equal to 1 liter. So you can either set it up like that ratio problem. Oops. So you can either set it up like the ratio problem, cubed and cubed. Those are two bad threes. So we could set it up with this where it's, okay, 1,000 times some number is going to give it to me, or I can just take what I have, 462.72 centimeters cubed, divided by 1,000.
Will we ever get a question where it asks like simply in milliliters?
Yes, at some point you will, and there's kind of a trick to doing that, which we'll explain. That'll probably is that? I don't think that's today, is it? I took a look. I don't remember seeing it. I don't remember if that's this class or in the next math class, but at some point, yes. But so this is pretty simple. All I need to do is divide this by 1,000. I'm going to get 0.4. It's 4672. Let's just round that up. 0.47 liters. So about half a liter is how much it can fit. Okay, so that's it. We're just really looking at prisms and cylinders right now. Tomorrow we'll probably look at spheres, cones, and pyramids. So we'll finish up this unit tomorrow. Probably, maybe. But for now, you guys can work on these practice questions up until I don't know what page is this on. What page is this? 42. So you can work on the questions from 42 to 48. If you're not sure, please ask for help. Because the two really important skills we need from this are understanding how to find like that base, like set up that formula correctly, and then learning how to turn volume into capacity. Those are two really important skills we need to be successful tomorrow. So you have time to work on questions from pages 42 to page 48. We are also going to have a concept check on the area stuff, 3.1 and 3.2. That's going to be tomorrow. So tomorrow we will have a concept check on 3.1 and 3.2. That is only the area stuff. There will be no volume concept checked until closer to the end of the week. So yes, there will be area. No, there will not be volume.